Alright, welcome to this next video, and we're going to be talking for this one about composite shapes, our first one for measurement. Alright, so composite shapes, your learning goal for this one is that students calculate areas of shapes, the volume and surface area of right prisms and cylinders. Remember, right prisms mean prisms that have a right angle between their projected length and their base. There's our rectangular prism, okay? All right, and at the end of this, you want to be able to analyze a composite figure into its separate parts and calculate the area of a composite figure or composite shape. Okay, smash them into pieces. So the key issue with composite shapes is being able to quickly break them up into the necessary pieces. So if you wanted to find the area of this random shape here, there's no formula for bizarre sort of Pac-Man-y shape thing, okay? So you're going to need to break it up into shapes that you do know how to calculate the area for. There's a couple of ways you could go about this very one here. So and it sometimes depends what kind of information you've been given. So I'm sure you can see that we can break this up here, and we're given so a triangle. There's a triangle here, there's a rectangle here, and there's a triangle here. So the area of this, I should make it Pac-Man's eating it, the total area for this thing will be the area, so I might actually call this area 1, area 2. Whoops, that's just not happening at all there, is it? Area 2, let's call this area 3. So the total area here will be area 1 plus area 2 plus area 3, okay? Fine, you can find the areas of those the rectangle and those triangles. Now, we could, however, let's draw this shape again, kind of. Oop, something like it. Right, so with one like this, instead, you can also do it by subtraction as well. You may be able to notice that we've also got a triangle here on the outside. So you could see it as a larger rectangular shape with the triangle cut out of it. And in this case, if we name the whole outside thing as area 1, and then this one here is area 2, the total area for this one would be equal to area 1 minus area 2. Now both of those will give you exactly the same answer. It depends on which way you want to go about it, what makes the most sense, and what's the sort of most efficient way of calculating it. Okay? All right. So the key ideas, firstly, as I showed you in that first bit there, you need to break the composite shape up into smaller, more basic pieces, okay, that you do know how to calculate the areas of. Then you use addition or subtraction to calculate the area of the larger composite figure, okay? And this one's really important. Make sure all steps are justified in your working. And that's some ways you can do that is by labeling the basic parts properly so that you can see what's going on, you know, that is area 1, area 2, area 3, etc. Okay, and so we're going to see that sort of working out in this next example, okay, and as well doing it logically. Okay, so going through it one after another, not just sort of like throwing it all over the place, all over the page. Okay, all right. Here's an example. No one knows the formula for crazy UFO sort of shape thing. Okay, so we're going to look at it, and I'll draw a little sketch of it so we can sort of think about how we're going to break this thing up. So there, we've got this round part, and the rest of the rectangle, and this thing coming down here. Okay, so I'm going to break this up such. So we've got a triangle down here, and a semicircle at the top here. So I'm going to call the semicircle area 1, the rectangle area 2, and the bottom triangular piece area 3. Now there are other ways you could go about this, I suppose, by subtracting the outside parts of here, but I think this one's best done by adding the different pieces together. Okay, so now let's go about working some of this stuff out. So first thing we're going to do is we're going to work out parts for area 1. Okay, so the area of a circle is equal to pi r squared. Okay, so therefore our area 1 is going to be pi r squared over 2 because it's only a semicircle. Okay, So pi times 5, 5 squared over 2. Chuck that in your calculator, you find it's about 39.3 centimeters squared. Please don't forget your units and stuff. It's super important. Okay, so that's area 1. Area 2 is our rectangle. Okay, so we're going to go straight into that. Area 2 equals length times width. And so that's going to be 14 times 6, and that's equal to 84 centimeters squared. And then lastly, area 3 is equal to the area of a triangle, which you hopefully should remember as half base times height. And so that's going to be half of 14 times 5, which you will find is 35 centimeters squared. So now we've done all that, therefore the total area is equal to area 1 plus area 2 plus area 3. So see how I'm sort of trying to communicate everything that's going on, so it totally makes sense to anyone who's reading this exactly what I'm doing. Okay, so area 1, area 2, area 3, so that's going to be equal to 39.3 plus 84 plus 35, which you'll find is equal to 158.3 centimeters squared. Okay, now, so composite figures are not difficult at all. It's really about can you break it up into the smallest pieces in the most efficient way. And once you've done that, boom, it's just a matter of calculating the different bits and pieces and working from them. Thank you so much for watching, and I'll see you at school.